Hi everyone. So let's see. Let's wait for a while. Let's see if we have few people. If we have few people, gonna get started. Okay. So hi everyone. If you can hear me, please can you comment down in the chat? Let me know that you can hear me. Okay. Mhm. Hi Rajat. Thank you so much for letting me know. We will wait few more minutes. We will give everybody an opportunity to join in. So yes, we have not many people on it, but still we have some regular people, and I would just wait for them, and we will start in 2 minutes. And meanwhile, if you can go give it a like to this stream, that would be amazing. So today we will be covering random value imputation. So first we are going to learn about when to use it, what are the assumptions behind it. We are also going to see when to use it, when not to use it, what kind of pros this technique have, and what kind of cons this technique have. So we are going to be talking about that first, and then I will show you how to implement it. Okay. So okay. So just one more minute. Let's wait one more minute and then we will get started. Yep. So, okay. So what I'm gonna do is I'm gonna quickly open up a new tab and call it random validation and we're gonna get started. View display and so we can get started now, I think. So once again, this is my morning. Good morning, everyone. And if it is afternoon for you, good afternoon. If it is evening for you, good evening. So, yep. So yes, we will get started. First of all, I will talk about quickly what exactly we have previously covered because Anybody who has joined me for the first time, they should know what exactly we have covered. So I will just quickly talk about what we have previously covered, and then I will talk about random value imputation. This is the technique that we will be talking about today. So what is random value imputation? Okay, so we will be talking about it. So this is our main topic for today. But we have covered a lot of different imputation techniques already. So what exactly are those techniques and which techniques we have covered? So first of all, we started with simple basic techniques. Uh, we started with, I think my software got updated and everything. So the first thing we covered is basically we started with complete case analysis. So we covered what exactly complete case analysis is, what are the assumptions for it, and what are the drawbacks for it, and why exactly I would never recommend you to use complete case analysis if you have a lot of missing data. So complete case analysis is basically what it means is drop everything missing. So anything that is missing, for example, like if any row has less than 5% missing values, I'm going to delete those rows. If any column has more than 5% of the missing data, I will delete those columns, which means we will only look at the complete case of the data, and that's it. Which means if you do this, you will end up with a very small amount of data. And if you originally have a very small amount of data and you got rid of a lot of data from it, you technically have no data or to work with for a machine learning model. So that's why this technique we did talk about. And then we also looked at that there are some univariate imputing techniques, and then there are some multivariate imputing techniques. So we have covered so far some of the univariate ones. And in univariate ones, we can further divide it into numerical, because the imputation for numerical columns is a bit different. So okay, numerical column is a bit different, and imputation for categorical columns is a bit different. Okay, now so this is one thing, and then what we saw is basically numerical. We have covered so far what is mean and median imputation techniques. We did cover both of them already. After that, what we did is we basically looked at arbitrary value imputation as well. So we have already taken a look at that. We have already covered that in our previous video. And then we also looked at end of distribution imputation as well. And we have already covered that in our previous video. In today's video, we will be covering random value imputation. So random value imputation, you must be thinking that, oh, how come it be different than the arbitrary or end of distribution? So random value imputation is a bit different. You would see, and this is one of the best. So keep one thing in mind. I'm going in a sequence where I will get to the best technique in the last. So I'm showing you all these easy techniques which are easy to implement and pretty straightforward. But then we are getting to some ones which are a bit complicated. Not complicated means it requires more number of steps in order for them to be implemented, but they are the best techniques out there among these univariate ones. So random value imputation is what we are going to cover today. So in our next stream, we will be covering that sometimes we can introduce a missing indicator. So missing indicator is just a binary value. For example, like even if you have used mean imputation. So when you are doing mean imputation, you want your model to know that whether the values were missing or not. So what you can do is you can induce another column in the data. For example, if you have already one, two, three columns, so you have three different columns. So in this column, you had some data. In this column, you had some data. In this column, you had some data. Let's say this data was here, this data was here, this was missing, this was here, this was missing, this was missing, this was here, this was here, and this was missing. So what I'm going to do is I will create one column for every column. So this column, I will create a missing indicator for it. So let's say this is an age column. So I will create age underscore NA column for this, and this would be this column. And what I'm going to do is, if my value is present, I'm going to give it a value 1. If my value is not present, I'm going to give it a value 0. If my value is 1, I'm going to give it a value 0, and so on. Similarly, I will create another column for this column as well. Let's say this is height column, HEIGHT. For some reason, why my marker is pretty. Yeah. So this is height column. So what I'm going to do is I'm going to create a height underscore NA column. And if my value is present, so this is present, I will put 1 here. If this is present, I will put 1 here. If this is not present, I will put 0 here. So I create an indicator out of it. Now you must be saying that, oh, this is a very extra work I can do. But no, missing indicator is basically there is a class in sklearn which you can use, which can do this for you automatically. So in our next video, we will be covering this. So this is what we are going to do right now. And then finally, in the univariate list of category, we will finally see that how to select the best technique automatically. So automatic selection of the best technique out of all those univariate ones we have done using grid search CV. I'm going to talk about it. Okay. Once I'm done with that, then we will get to the categorical one where I will show you what is mode imputation. Mode is also called most frequent value imputation. And then I'm going to also talk about that for categorical, you can also use the missing indicator thing. You can also use the random value sample for the categorical variable as well. And you can use an arbitrary category for categorical variable. So this particular technique, this technique, and this technique can be used for both categorical and numerical features. So I'm going to show you the implementation of arbitrary, random value, and missing indicator for categorical variable as well. So I will cover that in a separate video. And finally, what I'm going to cover is basically I will be talking about. So when we talk about arbitrary value, we in terms of category we give it a name. So for example, like I can replace all the missing values with the string missing. That means I'm creating another class, arbitrary value. So when we say arbitrary value, that means I'm creating another class. So this is something I'm going to show you. And then for multivariate, I will cover two techniques which are the mostly used techniques. KNN imputer. I will break down the complete mathematics of KNN imputer as I have been breaking down for every single thing that we have been doing. And I will also cover iterative imputation, which is also called MICE. What is MICE? We're going to talk about it. Okay. So today's goal is to cover this particular technique, random value imputation. Okay. So now, if you are right now in this particular video for the first time, do go back and check out the previous videos that we have covered. So we have covered the complete case analysis. So I have created a playlist handling missing data. So go back to that playlist and watch the previous videos. So complete case analysis is already there. Mean and median imputation is already there. Arbitrary and end of distribution value imputation is already there. This is what I will be doing today. So let's do random value imputation. So if you guys have any questions so far about the process, about what exactly we are going to cover, and let me tell you one important thing. Whatever I'm covering here, this is a complete end-to-end handling missing value thing you can find in any book or any paid courses on Udemy or Udacity. I'm telling you that I have created this particular list of categories or list of techniques that I'm covering here for handling missing data. I have gone through a lot of books, I have gone through a lot of research, and I have made up all these things in this particular way. And whatever I'm covering, I'm telling you this is the most extensive breakdown of these techniques that you will find on internet. Okay, and the best thing is for free. So I'm just doing it for free. I'm not means I'm doing these live sessions. I'm giving you an opportunity to talk to me, ask me questions if you have any, and if you don't have while you are watching the video, that's fine. If you have questions when you are trying to implement it yourself, come back to the video, put in a comment, I will get back to you. So I will, because I usually will be doing live stream. So previously I was doing Monday, Wednesday, and Friday, and that was too much for me initially. So that's why I dropped Monday. So I will be doing live streams Wednesday and Friday regularly every week. So in which I will be breaking down these techniques one by one. So sometimes if I skip any of the technique, for example, like if I get time, I will just record a video for one of the technique and I will just upload it instead of the live stream, because I want to cover as much as possible, as quickly as possible. And obviously, based on my timing right now on my side, it is 5 a.m. in the morning. So it's a very early time for me. So getting up at that time, I'm used to it. But preparing myself for doing all this, it takes up time. I mean, setting up my computer and everything. I'm not a professional streamer. I'm not a professional YouTuber. So setting up the equipment takes a lot of time for me. So okay. That's great, Rajat. Means if you have used KNN, that's amazing. But do you know how it works under the hood? If you don't know, we will cover that in detail. So I will break down the complete mathematics of it. So I will take a very small table of data, means I will create a sample data, and I will show you how KNN in the background works, how it goes and grabs the nearest neighbors. So I'm going to show you that. And similarly with the iterative one, I will show you all the iterations it does and how it improves the accuracy of the imputation that it does. Yep, that. Thank you so much for giving the feedback, Rajat. I really appreciate it, and I'm glad that you got benefit from it. Okay, so now let's quickly talk about random value imputation. First of all, what category or what are the assumptions for random value imputation? So when we talk about the assumptions, so the first thing is random value imputation works really well when you have missing data not at random, which means you have some data missing because of a reason, because of some condition, some natural phenomena or something else. So that means it is not at random, even if you don't have. So keep one thing in mind. This is the situation you're gonna get majority of the time in real life. Missing completely at random and missing at random are usually not very means they are pretty rare in the real life data. In the real life data, the data is missing usually due to a reason. And that reason can be because of the human error, because of the instrument error, because of one person is not doing the job properly, or something like that. So sometimes, or maybe sometimes, natural phenomena are the reason behind it. Means because of the bad lighting, you were not able to do something. Because of the bad weather, you were not able to record some values. So why the values are missing, that is very important assumption, because based on that your techniques usually changes. Okay, so when the data is not missing at random, so what you can do is that would be the first assumption. So this would be a good technique when you have data which is not in random and which is majority of the case. So which is usually majority of the case. Now the second point is, even if you have more than 5% missing data, this technique will work just fine, and we will talk about why. So which means, so far all the techniques that I have done, mean imputation, median imputation, complete case analysis, arbitrary value imputation, end of value or end of distribution imputation, all those techniques, they were doing good when the data was missing less than 5%. This technique, and you can see when you go and explore the data set which are available online, majority of the data sets have more than 5% values missing. Majority of the features, now any features which have missing values, majority of them which had missing values will have more than 5% missing. So that means we are in the right zone here. That means this technique would work just fine in majority of the data sets. So, and there is an advantage to this particular technique. So what is the advantage for this particular technique? The one important or the best possible advantage is it does not change the variance of the data. So it does not change the variance of the data. That is the first thing, which means I will talk about how it works, but right now I'm just talking about it does not change the variance of the data. So let's talk about this point first. So first of all, let me show you how this random value imputation works. So let me make a table here. So I'm gonna just create a table very quickly. So this is our table, and okay. So okay, so maybe I'll just get rid of it. So I'm just gonna create a table here like this. I'm just gonna create a box. So let's say I have a few kind of like values here. I have so for example, what I'm saying is you have an age column here, and then you have kind of like a height column, and then you have maybe weight column. So let's say one important thing, that you have an age of a person given to you. So age of a person is, for example, like 30 years, then 25 years, then this one is missing, then this one is missing, and this one is given, let's say 22 years, and then you have 21 years, and then you have 15 years. Oh, and then you have 18 years. So you have these age values given. And then for the height, similarly, you got 5.5 feet. Then you got 5.6 feet. And then you got 5.8 feet. And after that, you got maybe a missing value again. Or maybe what I'm going to do is I'll just leave this one for now. I will say that maybe 5.7. This one is missing. This one is missing. And this one is, let's say, 5.0. And this one is 5.2. Okay, so these are given. And then there's a weight column. I don't care about the weight column. Since this is a univariate technique, I don't care about other variables whatsoever. So let's look at the age column and let's deep down or deep dive onto the age column and see what happens. When I say random value, now what we do in the random value is basically you can see this value is missing. This value is missing. In this column, this value is missing. This value is missing. So right now I'm discussing this age column. Okay, so right now I'm discussing just this column. So if I'm discussing this column, how to pick the random values? First of all, I need to get all the values which are present. So which means I will create another variable and I will say age value, and I will create a new pandas series maybe, or I will create a new pandas. That's great, Rajat. Missing no is kind of like a library which is very easy to use, and yes, it saves a lot of time. Means I don't want to, means I'm a very big advocate of low code and high output thing. Means if you can get something done with one line of a code, then why bother writing 10 lines of code? So that is my take on it. So if you liked it and if you enjoyed it and people liked it, that's amazing. So let's get back to this particular column. So what I was saying is, now I will create. So this is a particular feature in my data frame. I'm going to create a new panda series or maybe a new data frame or whatever, which has just one column, which is the age column. And I will only keep the values which are present. So I will keep 30. I will keep this value 25. I will keep this value 22. And then I will keep this value 21. I will keep this value 15. I will keep this value 18. So what I did is basically I created a list of numbers over here. I can create a pandas data frame here for this. And now if I want to impute this value or this value, what I'm gonna do is I'm gonna go and now maybe I can create a numpy array. So numpy array would be what I would be using. So if this is a numpy array, from this numpy array, what I'm going to do is I will sample randomly any number from it. So let's pick random guess. So if I'm moving my hand, if you tell me to stop anywhere, wherever I stop, I will pick that number. So if I'm moving left and right, and if you tell me to stop, I will stop, and wherever I stop, that is the value I'm going to pick to impute this particular value. So if I'm moving and if you tell me to stop, if I stop here, oh, this is 22. So let's pick up 22 and replace this value with 22. What I'm going to do here is I'm going to replace this value with 22. For this one, I'm going to do exactly the same thing. I will again do it and I will pick a random. Oh, I stopped here, pick this one and replace this value with 15 here. Now you can see that what is happening. This is what's gonna give me an kind of like, let's say this is the distribution of my age column originally. That means the probability of picking any value which was here, which was here, which was here is something, right? Which means the missing values would be filled by majority of the values which are in the middle, some values which are here, 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 based on their probability, because the probability of this particular value or values which are in this particular range would be less than the values which are in the middle. Similarly, these values and these values. So what is happening? Some values I'm filling up with the mean and median. Some values I'm filling up with the values on the less than mean and median. Some values I'm filling up with more than median value, and it is all random. So when you are using randomness, that means if your data is already missing not at random, that means those values. So right now you don't know whether to use mean would be a good value, median would be a good value, arbitrary value would be a good value, end of distribution would be a good value. In random imputation, what we are doing, we are taking a mix of it. Some values are being replaced by mean and median. Some values are being replaced by somewhere bigger than mean and median. Some values are less than mean and median. Some values are at the end of the the distribution. So it's all techniques combined together, you can say, we are being using. So which means these techniques, this technique does work well. And why it doesn't change the variance of the data? Because I'm picking these numbers, and these numbers are picked randomly based on their occurrences. The more number of times they are occurring in the data, the more chances for them to be picked up. And if less number of those values are in your data, the chances for them to be picked up is less. Okay, so why it is the case? It's simple. For example, if I have some values 2, 2, 2, 2, 4, 4, picking up, so do I have more probability of picking 2 or 4 in this scenario? Can anybody tell me what is the probability of picking 2 in this scenario? So I have 1, 2. So I have this value, this value. So in total, I have how many values? 1, 2, 3, 4, 5, 6. So I have total 6 values. 2 is repeated 4 times. So probability of 2 is 4 over 6. So that means absolutely. So it is 4 over 6, which is 2 over 3. And 2 over 3 is 66%, or simply 2 over 3 is 0.667. And if you multiply it with 100, you can convert it into percentage, and you will end up with 66 or 67%. Yes, that's right, Ratu. So similarly, what is the probability of picking up 4? It would be simply 2 over 6, which is the remaining 33%. So that means if my data has a particular distribution and a particular number has been repeated more number of times, that means I am keeping the number of balance or keeping the probability same. When I'm picking random numbers, technically in the background, what is happening, the probability of this particular number in the data is still kept almost the same value. And similarly, the mean value is also the same, median value is also the same, median value is also the same, this value is also the same, this value is also the same, this value. So what is happening over here by picking the random value? So it does not change the variance. Since the probability is not changing, the overall variation in the data is technically not getting affected. That means if I had 66% values, which means I will replace about 66% of the missing values with 2 if I just had these two values, and I will replace about 33% of the values which were missing with 4. This way, my overall variance and overall distribution of the data would not change. So first thing we covered that it does not change the variance. And the second thing is it does not change the distribution of the data. So it does not change the distribution of the data as well. Okay, and that is something very amazing. And when I talked about variance, which means if the variance of the variable is not changing, then the covariance with the other variables would not change as well. And covariance is very important because we are trying to find the relationship of one feature with the other. That means if the variance of one variable got affected because of the imputation techniques, technically you distorted or disturbed the relationship that existed in the original data, and we don't want that. So covariance not gonna not affect it. Similarly, if covariance is not affected, variance is not affected. So from variance, standard deviation is not affected. That means correlation is not going to affect. So correlation will not be affected as well. So far, this technique has so many advantages which all the others did not have. So, Rafi, that's a good question. What happens if the variance is disturbed? So, if you have large enough data set and you have means even more than 5% missing data. Obviously, if you have 95% of the missing data and you are trying to use this technique would not work fine. So obviously, you should not have that many missing values. Even if you have 30-40% missing values, I'm telling you, your data distribution would not be affected in a big way. And I will show you on a data set which has a lot of values. Okay, so if it changes, then it is not a good technique to use in that data set. Yes. So if it is changing, that's right, Rafael. If it is changing, then the good way is basically go by the multivariate techniques. So go by this KNN technique or this iterative technique. So usually my go-to techniques are these if these techniques does not work. Keep one thing in mind. These techniques are computationally expensive. So which means you should always go to these techniques if these techniques are not working fine. Okay. So that is because these techniques are very easy to implement. Just few lines of code and you are done. sklearn or these kind of libraries have already made it easy for us to write less code and just put the parameters in and you got the answer. So even though the code is low for them, but the computation power is pretty high. This, if you have a lot of data, KNN imputer will take forever to impute the variables or impute the missing values. Similarly with the iterative one, because it is iterative, the name is telling you that it repeats the process multiple times to get to the best possible answer, which means it is computationally heavy. So these techniques, yes, these are the best techniques, but these are the most computational techniques. So cost heavy techniques as well. So someone is promoting some um, I need to okay. So let me just remove these. Okay, sorry about it. And I was saying. So this is what I was talking about. So when you have a lot of data and these techniques are not working fine, so the reason behind me telling you all these techniques is you have to do hit and try, and that is the reason why data cleaning is the most time expensive part of any data science project. So data cleaning would take a lot of time. You need to spend a lot of time applying these techniques, which techniques works well and everything. So I'm also building or working up on a Python library where we can apply these techniques automatically in a sequence, and it can do it automatically for us. If anybody wants to be part of it, do let me know. I can get you means you can contribute in that. It would be an open source Python library. So I started working on it 2 weeks ago. It is still a work in progress, but if anybody is interested, do let me know. Okay. So, okay. So we talked about these many pros right now. Okay, so that means so far, out of all the techniques, even if we have a lot of data missing, it is taking care of the variance, distribution, covariance, and correlation. So, but it has some cons as well. What would be the cons? So keep one thing in mind. Uh, I forgot about one of the positives as well, which is keep one thing in mind. A lot of linear models or all those parametric models, uh, they assume the distribution of the data to be normal. And if you have normally distributed data, then this technique would not distort the distribution sense, which means the linear models or those parametric models would work absolutely fine. Sounds good, Rajat. Um, so linear models would work just fine, or parametric models. So what are parametric models? So when you read the word parametric, parametric means they need some parameters, some assumptions to be true in order for them to be applicable. So non-parametric, so real life decision trees or something like that, they are non-parametric. So that is the reason why they perform really well in a lot of real life situations, because in real life there are very few relationships which are linear. And if you want to predict non-linear relationships, non-parametric models would be the thing to go. So, but linear models are very simple and they are very explainable, and these parametric models as well. So since they are very explainable, so they are ideal. If you can get the model developed using linear models or parametric models, your model would be very explainable and easy to understand, because explainability is a very big issue in machine learning and data science. So if you are using a technique which takes away your understanding of the data, that technique you will try to avoid it. Even if you have to suffer less accuracy, you usually try to avoid it. That is only used in the competitions and everything where you want to get the best result. But in real life, you try to use things as simple as possible. If you try to go complicated things, those complicated things are difficult to explain and difficult to understand. And when you are trying to understand the behavior of the people from the data that you are gathering, then you need some explainable techniques to be used. So that is where this particular technique would come in handy. So let's talk about the cons now. So for the cons, the one important thing is this particular technique is it's not ideal. You can say it is not ideal for deployment. Why is that? So why it is not ideal for deployment? Because you need to keep storing the values of every column which has missing values in your cloud. So which means it's not like just deploying your machine learning model at the end. You would have to save up some space, or you have to use up some space in the cloud for these values, because this technique is getting a random value out of a particular value which were present in your data already. So which means you need to save these values here. So it is dependent on that. If it is dependent on that, this particular extra variable that you created, it needs to be saved in the data set. And if this data set is with million parameters or million features, not million features, million instances, and it has several features, and you are storing all those features, yes, it is going to be very expensive. So which means this technique is deployment heavy, and this technique is very heavy on the deployment. And If so, here you have to do the cost and benefit analysis. What cost you are spending and what benefit you are getting. If the benefit is more and cost is less, then go ahead with this technique. But if the benefit is not as much, but the cost is too big, then try to avoid this technique. So every technique we have seen so far, it has its pros and cons. So you can see that some techniques are pretty simple, but they have a lot of cons. But every technique has pros and cons. So you need to know all those pros and cons so that you can decide for yourself in which technique, which particular in which situation, which particular technique is going to work well for you. So that is a tricky thing. Okay, so that is one of the major con of this particular technique. And other thing is, if you have more than 50% data, I would say, then don't use it. So then it will distort the distribution. If it distorts the distribution, everything that was bad with the distortion of the distribution with all the other previous techniques would come in here as well. So which means if you have greater than 50% of the data missing, then it will distort the distribution and it will change the variance and it will change the covariance and correlation. So everything is going to change and it's going to affect your overall relationship with all the other variables and the model as well. So all those bad things come into play as well. So if you have more than 50% data, so this number is arbitrary. I'm just telling you a number from my experience, but this number is not well written or well defined anywhere. I'm just telling you, or I'm speaking just out of experience. Okay, so I usually try to avoid this technique if I have more than 50% data. If I have more than 50% data, then that variable is very tricky, and then you need to go in detail and see what is going wrong with that variable and do a lot of detailed research on it and then get the best possible technique. And that is what I will not be able to cover in these sessions because that is pure research and that is domain expertise come into play as well. So majority of the time you would have some domain experts in your team, and those domain experts would be doing the job on that. Yes, Francesca. Complete case analysis is for 5% or less, but keep one thing in mind. If your original data set is pretty small, then even that 5% is very costly or very expensive. So you have valuable information. So keep notice of complete case analysis that you are dropping all the rows and then you are dropping all the columns which have more than, so which means you're only left with complete cases only. So be very mindful of that. You're not dropping too much data when doing complete case analysis. If your data is still good enough while doing complete case analysis, go ahead with complete case analysis. That would be the first thing I would ever do if I'm not dropping a lot of values. If I don't have a lot of missing values, then complete case analysis would be the easiest and the most straightforward thing to do. Rajat, you were saying for 50%, wouldn't CCA be a better option? That is what I'm saying. CCA dropping the complete columns. So I'm always, when you have valuable information, so for example, 60% of the data is missing or 70% of the data is missing. Keep one thing in mind, when that high value is missing, then you need to go and check why the data is missing. You need to understand that variable in detail. So you have to do a lot of research in order to do well in it. But if you are just doing a project, for that purpose, just drop that column. That would be fine. Okay. So when you are doing portfolio projects, you just drop that column. But when you are in a company and in that particular scenarios, when you are doing some naive models and everything, for example, like your first initial attempt, yes, you can make the model as simple as possible and you can drop it. But eventually you would have to work on that particular column and learn why the data is missing, and how to get that data or fill in that data or impute that data. So you would have to eventually learn, and over there you would go back and forth between the people who are collecting the data and who are gathering the data. Go to the company and talk to them that why data is missing and try to understand. So it is kind of like a total different process when you're doing a project where you are just getting the data from Kaggle or something. Just dropping it, doing the CCA part, just dropping that column would be the thing to do. Yeah, that's right. Okay, so if we are good with this, then let's get on to the coding part. So coding part is pretty straightforward for this one. Okay, so I'm gonna go with pretty straightforward things. So what I'm gonna do is I will go to Kaggle. So I'm gonna go it with you. So I will go to Kaggle. My account is already logged in. So I will get one of the data sets. So which computation? So I am using which datathon data. So this data. So I'm going to use it. So this is which datathon for the impact challenge, or so I think this is the second phase. I will just go with the first one. So which datathon 2022. Oh, let's go to data sets. Which data on 2022. So what I'm gonna do is maybe just go here. I don't know what is happening. So what I'm gonna do is I will just go to one of the notebooks here that I created, median imputation, and I will go to this data set. This is the which datathon dataset. You can I will share the link on my GitHub and you can have access to it. So what I'm gonna do is I will go to the code and I will create a new notebook. So when I create a new notebook, let's give it a name. So we are doing random value imputation. Okay. So we are doing random value imputation over here. So when I'm doing random value imputation, so first of all, let's run it and let's see. Let's start the kernel. So it is preparing to download the dataset. Let it download the dataset. So I think it has the dataset now. You can see it has already downloaded the dataset. Now the dataset is there. I'm going to be working on this train.csv file. Okay. So I will try to keep things simple. I'm just trying to show you here how to do it. So first of all, I'm gonna import some libraries. So I will be importing pandas as PD. I will be importing NumPy as NP. I will also be importing from sklearn.model underscore selection import train test split. Okay, and what else I would be importing in? I will import maybe matplotlib and seaborn because I want to show you the distribution as well. So import matplotlib dot pyplot dot as and then I'm import seaborn as SMS. So let's import all of these. Okay, so we have imported we are importing all these libraries. Let it take some time. When we are done with importing, what we are going to do is we are going to bring in the data frame. So let's read the CSVs. So PD dot read underscore CSV, and here I'm going to get the input, and that is dot dot dash my input. So what I'm doing here is I'm going to, so this is my input. I'm going to this folder first, then I will go to this folder, and inside this folder I'm going to this train.csv file. That is what I'm going to do here. So first I will go to input, then I will go to this width datathon. Let's copy it. Let's copy this over here. And then slash I'm going to do train.csv. So that is what I'm going to do. And what else I'm going to do is I'm going to print the head of this particular data set. Let's call this data set, open it, and so you can see this is the data set we have at hand. So it has a lot of columns. Just to make things simple, what I'm going to do is I'm only going to pick out few columns which I know. So I have been working on this data set previously, so I know which column has missing values and everything. What I'm going to do is I'm going to pick up maximum wind speed as one of the column, and the other column that I'm going to pick is energy star rating. Where is energy? So energy star rating. This is what I'm going to pick, and so those would be my x values. So maximum wind speed and energy star rating. So if I want to pick those, what I'm going to do is I'm going to simply define my x variable. So let's say my x variable is df, and which variables I'm picking up. So I'm picking up energy star ratings. Is that ratings? Let me go and double check the spelling. Energy star rating. That is what I'm picking up here. And the second thing I'm picking up is max wind speed. So let's copy this and let's paste it here. So I'm going to paste it. And then I'm going to define my y variable, which is df. And here I'm going to use site EY. This was the last column that you see over here. So this site EY is what we are predicting. So I just created my X and Y column because I'm going to show you the standard steps that whenever you are trying to do some transformation, some imputation on everything, the first thing you always do is split the data. So that is what I'm doing. I'm creating my X and Y variables, and then I'm going to split it, and I'm going to do everything on train, and then I will implement it on test as well. Because test data is usually means it is for every single time. So Dion, the link to the data set. So I will share the link to the data set. Let me open it again. So I will put it in the description of the here. So usually what I do is basically I show it on my GitHub portfolio, GitHub profile as well. So I have made a complete GitHub link for it. So let me show you here. So this is end-to-end machine learning course. I have created this. So I usually give my the link to the data set and everything. So I will put that in the description of this video as well. So feel free to check it out. But it is simply with Datathon 2022 dataset. Okay, and let's see if I can give you the link right now. If you can access to it, let me go to the details of it. Yes, I can put the link to the dataset. So I have just put in the link to the dataset in the description of this live stream. Please go check it out. You have access to it. Okay. Okay. So let's get back here. So what I was doing is I'm just bringing in these. So let's print in the x and y. Let's look at x. Head of x. So when I look the head of X, it looks something like this. And if I print the head of Y, it looks like this. So this is side UID. Okay. So what is the next thing I'm going to do over here is I'm going to simply I'm going to first of all split the data. So let's split the data. So I'm going to do x underscore trained comma x underscore test comma y underscore trained comma y underscore test is equals to train test split. I'm calling it from sklearn, and then I'm going to take the x variable and I'm going to take the y variable, and then I'm going to say test underscore size equals. So I'm taking about 70% as my training set and 30% as my test set. So I will do 0.3, and then I will determine the random state. So random state, I usually go with 22. You can pick any number. It is just the number I'm sticking with. Means when I was in my undergrad, this was my roll number, 22. And all my email address, all my IDs are basically 22. Means my LinkedIn profile, my GitHub profile, everything is Salman Khalik 22. So 22 is kind of like my number. I just use it. You can use any number you want. So let me split the data. So if we split the data, we have, so let's take a look at x underscore train. So x underscore train looks something like this. Let's print the head of it. I don't want all of it. So you can see this is the x underscore train data. It has been shuffled in the by the train test split. That's why you can see these numbers are different over here and they're not in order. So you can see there are a lot of NaN values. Let's take a look at how many NaN values does it have. Okay, so let's find the number of NaN values. So for that purpose, what I can do is I can do one simple thing. So I have previously, in fact, let's take a look at the shape. And, I can also look because I want to know how many values do I have. X underscore train dot shape. Um, let's print it. Okay, so I have about 53,000 data sets here, and I have two columns. So that is amazing. So let's print out x underscore train. And what I'm going to do is I'm going to figure out how many null values it has. Is null. And then I will find the mean of it. So when I do that, you can see in energy star rating about 35% of the data is missing. In max wind speed is 54% of the data missing. Okay, so which means we have a lot of data missing here. So what I'm going to do is I'm going to now implement these things step by step. Okay, if you want to calculate the percentage here, what you can do is you can simply multiply it with 100 if you want to. So this is 35%, 54%, and we are good with that. Okay. Next thing what I'm going to do is I'm going to simply create a new data column. Remember when we were talking about this over here, I said I need to create a separate NumPy array or pandas data frame or something. So here what I'm doing is I'm creating a separate column. Instead of creating a separate NumPy array, I'm creating a separate column. I can do that. Okay. So what I want to do is I want to so okay. So what I'm going to do, should I do that or should I think I should do this way. Okay. Let's create a pandas data series maybe. So what I'm going to do is I'm pick up random underscore. In fact, let's give it a variable. So I'm going to call it number of NA in what column? In x underscore train. So, or maybe train is equals to x underscore training dot. So this is what I'm going to do. So I'm saving it in a new variable. So what does that mean? Let me print it out. So number na underscore x underscore train. Let me print it. You can see it prints out something like this. Okay. And here what I can do is I can do it for separate columns. Um, so what I'm showing you here is I'm showing you for one column, and then I will show it for the two columns together. So first column, maybe let's pick up the energy star rating, energy underscore star underscore rating. This is what I'm doing here. So when I do that, you can see it only gives you the percentage of missing values in the energy star rating. Okay, and if I change this to the max wind speed, it's going to give me the value of max wind speed. So what I'm going to do is over here I'm going to return it back to energy star rating. So I'm just showing you what is happening over here. Okay, now what I want to do is I want to get a random sample from this particular column. So maybe I'm going to do sum instead of mean. So previously I was doing the mean and I was calculating the percentage, but then I realized that I don't want the percentage. I want the total number of values which are missing. So these are the number of values which are missing in the energy star rating. So how I'm going to use them to pick out the random sample, I'm going to do something like this. I will create a variable random underscore sample underscore train, and I'm going to do what x underscore train, and which variable I used it for, energy star rating. This is what I use it for, energy star rating. And first I will drop all the video. So keep one thing in mind, I only want to pick the values which are present, don't want to sample the missing values. So first I will drop the values, so drop na, and then I will sample from it. How many samples I'm going to take from it, how many values were missing. I had 18624 values missing in energy star rating. So I'm going to sample how many values from it, this many. So I will copy this number, and this is going to tell me this number of values. So this would be the energy star rating values over here that I will be picking, and then I will determine a random state, and this would be again 20 to 40. So when I do that, now what this is picking is, it is picking up 18,000 whatever, so however values were missing. So let me put down a code here. So what I did is basically I went into energy star rating column, I dropped all the null values. When I dropped all the null values, I'm left with all the values which are present, and out of those values I'm sampling 18,624 random values using this random state. So I'm picking those values, and what I can do is now I can fill in all the missing values using those 18,624 values into my original data set, and I'm done with my imputation. Okay, let me show you how to do it. So how to do it is simply, first of all, I will go to the random random underscore sample underscore train. So I'm calling this particular variable here. That is first thing. Then I'm going to the index of it, and I'm defining what would be the index of the random sample train. So I want to figure out the index of all the missing values here, and that's where I need to fill in the values. So what I'm going to do is x underscore train, and then I will open up energy star rating column, and then what I'm going to do is uh, in fact, let's put it in underscore train. Let's put it in this. And then what I'm going to do is I need to figure out the index of all the null values is null. That is what I'm going to do. And then I'm going to find the index of it. Dot index. So what I'm doing here is I'm getting the index of all the values which were missing in my energy star rating, and I'm getting the index of it. Once I get the index of it, then I will go and I will fill in the values that I captured here into that particular column. So we are going to do that. So I did that. So this is what we got over here. Okay. Now what I want to do is let's replace the missing values in the original data set. So now what we are going to do is we are going to be replacing the missing values in the original data set with the randomly extracted values. How we are going to do it? It's pretty simple. X underscore train. Then I will find the location of which variable, X underscore train. And then I will go to energy star rating column. So that is the first thing I'm going to do. And I'm going to do is null. So I'm going over here and I'm going to this particular specific location. So I'm going to go into all the values of this column which are null, and then I'm going to give it a name, and I would call it energy star rating. And then I would put it equals to what? The values that we got over here. I'm going to fill in this. So now if I check my energy star rating, how many missing values it has? Let's check again. So this is what I'm going to run all over again. So when I run all over again, you can see I ended up with 0 missing values. If I plot my x underscore train dot head, and if I print in the first 10 values, you can see originally my x underscore train had some missing values, right? So where is my x underscore train? I did not print it. But over here, you can see that these are first 5 values of energy star rating. They were originally there, but I think I have changed it. So originally, I had a lot of missing values. How many? Over about 18,000. But now I just dropped it because I think I have to run it all over again, which I'm not going to do it. So you can see all the values which got filled in, they are random values. So this value is 28, 21, 16. You can see none of the values are kind of like repeated here. So what I was able to do is I was able to fill in this particular column. And I can do exactly the same thing for max wind speed as well. So I can repeat these steps. What I can do is, first of all, I can pick a random sample of the values here using this particular thing. I'm going to copy this and I'm going to paste it. Okay, so that is one thing. Or the other thing is you can run a for loop. So if you had more number of variables with missing values, what you could do is you can do a for loop. So how would you run a for loop? You would say for a variable in the series of list, for example, like energy underscore star underscore rating, and then you have max underscore wind underscore speed, or if you had some other variable other than that, you can do it in that particular sequence. So for all the variables in these particular list of variables, what we want to do is, first thing we want to extract random sample. So let me write in the code what exactly I'm doing. First, I will extract the random sample. So random underscore sample underscore train would be equals to x underscore train, and then I will put in which variable I am working on here. First, it would be energy star rating. Since I have already done that, then it would be max wind speed. So variable. First, I will drop NA. Once I drop the NA values, the second thing I'm going to do is simply I'm going to sample some values from it. How many values? I'm going to sample x underscore train uh, this variable, and then I'm going to do is now how many null values do we have? I'm going to sum them. That many values I need to sample. So I'm going to do that, and then I need to define the random underscore state equals 22. So first thing, I extract the random sample. The second thing I'm going to do is I'm going to in fact repeat it for the test set as well, because this is the training set, right? So I'm going to repeat it for the test set as well. For the test set, I'm going to just copy this all over again. I'm going to paste it here, and I would call it test. Keep one thing in mind, which means I still have to do exactly the same thing here. Okay, but keep one thing in mind here. I don't want to replace the training values. I need to replace the testing values. So over here, when I'm sampling, how many samples I need to take? All the missing values which are in the test set, not the training set. So I will do it for test here. So I'm still sampling from the training folder or training column, but I'm filling in the testing column. So that is what I'm going to do. So this is what we will be doing. The next thing we will be doing is we will be re-index the randomly sampled values. Okay. So we will be doing that. So how did we do that? Let's go back up here. We indexed this particular way. So let's copy this and let's paste it here. So I'm going to paste it here. So I'm going to call it random underscore sample dot train dot index, and I would say x train, and then instead of energy star rating, I'm going to call it a variable since we are running the for loop. Variable. So we got to the variable, and the next thing is null, and then I'm going to the index, and I'm going to do it the same thing for the test set as well. So here I'm going to do it for the test as well. So test dot index, and here I'm going to do test, and here I'm going to do from the test. Okay, so I'm just getting the index of the test set, just like I'm getting the index of the training set. So, and the next thing that we did was replace the NA. Replace the null values. So how did we do that? Let's go back and copy the code. So we replaced the null values using this log technique. So we went there, and instead of energy star rating, I'm going to call it var because we are running the for loop. And here I'm going to give it the name as the variable name, var, and I would call it random sample train. So let's copy this whole thing and paste it for the test set as well. So this would be x underscore test, and this would be x underscore test, and I think that's it. So when we run it, we should be able to, let's run it. We got an error. So cannot take a larger sample than population. when replace is equals to false. So we did not put something. So replace is equals to false. Okay. So did I miss anything? Let's go back and check the code. So let me compare. So extrain variable drop NA, and then we have taken a sample. The extrain variable is null, and then when we are taking a sum, and then we are defining random state. Then we are doing it for the test set as well. So it is extrain variable. Oh, my bad. So this should be test. Since I have cannot take a larger sample of the population when replace is equals to false, random sample tested and trained. This is something I need to change. This is variable. Nope, still not, because we copy pasted something. So I think we left out something. Let me double check. So extrain variable. This is part of the troubleshooting. In the last line of code, it has to be random underscore sample underscore test. We did that. It is still not working fine. Let me double check. Test underscore variable. So this one is fine. Extrain x underscore train variable is null. And then we indexed it. Test x variable indexed it. Let's rerun all of it. So let me import the data set and let's distribute, because I think what it has done is it has basically already copied something and it has changed it. So let me run it again. So what I can do is I can just go back here. So let's take a look at head of the train. Originally, you can see there are a lot of missing values, but let's run this again. It's still running. Cannot in numpy.rand. What about line 2? So did I write the names correctly? Energy star rating, max wind speed. Let's go up here. Energy star rating, max wind speed. So this was working fine. So let me run this here. So what went wrong here? So let's create this, which means this one has already gotten rid of this. So if I run this again, you can see this one is fixed, but max wind speed is not fixed. So max wind speed is not fixed. So something is wrong with the second variable, max wind speed. So what that is doing. For the variables under random underscore sample underscore test. This thing, are you seeing? No, this should be trained, because I cannot sample from the test set. Test set is usually unseen, and I cannot sample it from the test set. So this is something very, very important. Sounds good, Francesca? So this is very, very important. This should be. So let me run it separately for the other column as well. So let's run it here for max wind speed and see if it is working. If it is working, then maybe there's something wrong in our code. I have put some comma or something. Max wind Let's run it. So it has 28,000 missing values. Then let's copy it here. So this is where the error is. X underscore train, max underscore win underscore speed, drop in it, sample. Okay, so you know what is happening over here, everyone? Look at that. How many values are missing here? So I have 28,000 values missing. This number is bigger than 50%. Remember, I told you if you have more than 50% values missing, then you're gonna get errors and it is not feasible. What is happening over here is you have about 54% of the data missing. If the data is 54, above 50%, which means I'm asking it to sample 54% of the values, even though it doesn't have that many values. So what it is doing is I'm asking it to sample from a small set of values and I'm asking it to sample more values than it already has. That is what is going wrong here. And this is the reason why I wanted to show you. Means maybe I it's in my mind, but this is what I said. So replace is equals to false. So what we can do is we can do replace is equals to false in the sample. So over here, if I say replace is equals to false, then it should work. So that is the reason why I would add replace is equals to false. And if I do that, it should work. Let's put it true. Only integers accepted as values. Okay, so I changed this to mean. Now it should be able to work. Yep. So what I need to do is I need to do replace is equals to true over here. And that is what was missing over here. And this is something which you need to go and troubleshoot. And I wanted to show you this troubleshooting part. I'm doing it live. I haven't done it before. Otherwise, I would have looked in my code. Okay. So I'm showing you what I'm doing on the spot. Okay. So since I'm doing a sample of it, so over here, what I need to do is I need to say replace is equals to true. So when I say replace is equals to true, that means the values which I have already picked originally, I want to sample from it all over again. When I originally in the built-in version of this dot sample, so if we go to the kind of like uh, pandas dot sample, so if we go to pandas dot sample, you can see that it has this replace function originally to be false. When this replace function is originally to be false, it tells you allow or disallow sampling from the same row more than once. If you want to sample from the same row more than once or not. Since we want it to sample from the same row once, because if I do not allow it, it's not gonna have enough values because 56% of the data is missing. That means I only have 44% of the data available. And out of 44 means, let's say if I have 100 values, out of 156 are missing, 44 are there, and I'm not replacing the random values that I'm picking, which means I can only pick 44 values. I cannot pick 56 values. So I need to turn this on. Replace is equals to true. Okay. So if I'm doing it here, then I need to do it here as well. So let's run it again. When we run it, now it is working fine. Let's take a look at our data set. Okay, so let's take a look at our data set. Let's look at how x underscore train looks like. So x underscore train looks like this. You can see I can pick maybe 10 values. So you can see that, or maybe I can sample 10 values, random sample values, not just the top of it. You can see randomly all the values are picked up. They're not being replaced by those values. And let's do the test one as well. X underscore test. This is what the test looks like. Good. So this is something which you need to be aware of when you are kind of like working in these particular situations. Now, I already showed you all these stuff and everything, but I want to show you the plot of the original one and plot of the new one. But one thing that I did wrong here is I created it in the same. So over here, what I did is basically I'm creating the name of the variable as it is. So what I can do is I can go back and I can change the name of the variables if possible, or I will just give them a different name, and then I want to plot them. Okay, so what I can do is I can go here. I will read it again, all over again. So let's split it. And what I'm going to do is I'm going to save x underscore train uh, so uh, original is equals to x underscore train dot copy. Okay, I just copied it here, and I'm also going to copy x underscore test underscore original is equals to x underscore test dot. So I did that. So now I have x underscore train underscore original, and I have x underscore test underscore original. Now I'm going to compare them. I will plot them and I will compare them. So first thing I'm going to do is I imported the C1 library. So SNS dot dist plot, and then I'm going to do x underscore train um, then underscore original. I think I need to run this all again. Yes, x underscore train underscore. So first I will plot the original one, and which energy star rating. Let's plot energy star rating first. Star rating. I'm plotting it. So energy star rating. I'm going to give it a label. I would say that it is original. Let's make it. So it is original, and then I will drop the I don't want the histogram, so I will do it false. Then I will plot on the same graph the disk plot of the new transform one x underscore train. And then I will go with energy rating, and I will call it label is equals to imputed, and I would say hist is equals to false. Then I will turn on the legends, and then I will show the picture. What did I do wrong now? Rectangle object has no property hit. Rectangle object. Huh? Rajat, so you are saying no. Keep one thing in mind. If I'm repeating some values, which means the values which are repeated more, I will be picking them more, and the values which are repeated less, I will be picking them less. So the distribution would not change. my overall distribution would be same. The probability distribution would not change. Does that make sense? For example, like the example that I gave you with four twos and two fours, that what would be the probability of picking up twos and what would be the probability of four? So if I'm picking this two and putting it back, which means picking up of this two all over again, the probability would not change. So if you change the probability, then the distribution would change. So we don't want the probability to be changed. That's why replace is equals to true would be better for us. Sounds good. So over here, maybe just get rid of this. Why I was doing this. So I think I did it wrong. It is this plot. I'm doing this plot, and that was the mistake. My bad. Test is equals to false, and I'm gonna do test is equals to false. Let's do it. You can see the original and imputed one. The distribution is pretty much same. In fact, exactly same. Yes, there is some overlap and everything. There are some values up and down, but you can see the power of random imputation here. Does that make sense? If that makes sense, then what we can do is we can look at the variance of the original and imputed as well. Did that change or not? Remember, I said that variance does not change. The distribution does not change. So we just check the distribution does not change. Let's check if the variance changed or not. So what I'm going to do is I'm going to print. First of all, let's print. Let's prettify it. So original uh, variable variance. So that is what I'm going to do. So I want that to be maybe let's do this one. So maybe let's give it a space here, and I will put it here. Underscore and since I'm talking about original, so uh, original, and then I'm going to energy star underscore rating. When I'm doing energy star rating, and I'm going to take the variance of it, and then I'm going to plot print the variance of the imputed one. So it is variance for random imputed variable variance. Imputed variable variance x underscore train underscore original. I will just get this. So let's print it. You can see the variance is very, very, very same. Does that make sense? So you can see that this random value imputation is very powerful. Even though I had 56% data missing, 35. So right now we are doing energy star rating. We haven't taken a look at the other one. So let's do the other one as well. So instead of energy star rating, let's look at max underscore win underscore speed. So let's see if it changes or not. Look at that. I had 56% values missing. Yes, this value kind of like bumped up. That means I'm doing more mean values are being added here, but the rest of the other values are added in equal numbers with equal probability. And if I look at the variance here for that variable, you can see that the variance is still 4141. Isn't that amazing? I was able to keep the distribution of the data same, variance of the data same, standard deviation of the same, covariance with the other variables same, correlation with the other variables same. So I was able. So let's check the covariance maybe. Okay. So what I'm going to do is x underscore train. Uh, uh, so x underscore train underscore original. So what was the covariance originally of the original variable? And then I'm going to do dot covariance. You can see that this is the original one and this is the imputed. So energy star rating with the max wind was negative 0.14, but this is 0.92, so it got changed. And max wind speed um, with energy, so it did get changed. Since the values were a lot of values were missing, and when we replaced them, the distribution did get changed. So covariance did get changed. So that is the reason why if you have more number of missing values. So we were dealing with a lot of missing values. I was hoping that I would get a good result, but no, I did not. So which means covariance did get affected. And if I talk about correlation, so if I do 4 instead of correlation, did the correlation change? Correlation would definitely be affected. So so correlation did change to from negative to positive. So if covariance changed, correlation would change. Since the values were a lot of values were missing, and when I replaced it, it changed the overall correlation and covariance, but it kept the variance same. You can see the variance did not get affected, the distribution did not get affected. So we still got some benefits out of it. Okay, so we still got some benefits out of it, even though we had a lot of missing things. Okay, so and if we look at the maybe in fact right now I can just okay, so I think this video has already been too long, so I think let's finish it off here, because if I keep on talking about means I can check with the box plots and I can check with so many different things here, but I think I will hold on to it over here, and that will be fine. So these are future warnings. You don't need to worry about it. If you want to just mute them, you can type in here import warnings, and you can type future means silent future warning or something. You can do that. Or if you want to search how to silent future warnings Python, it would tell you what to do. So use filter warnings function to suppress warnings in the future. So you can use that. Okay. So I always copy and paste it from it. I never memorized it, so that is what it is. If you want to, but I usually do not do that, because this is a very good way to kind of like see that what's going to change in future in different packages and everything. So that is a good way to see that. Okay. So I think uh, that is it for today. If anybody has any questions, please feel free to write down in the comments, in the chats. If not, then thank you so much. If you haven't liked the video, please like the video. And if you haven't subscribed to the channel, please subscribe to the channel. And if you can spread the word about the channel, that would be amazing. I would really appreciate it. Thank you so much. I would just close the session now. Have a good rest of the day to everyone.